All right, so in our last lesson, we basically just set up a ball and a box. The ball bounces on the box, and that's about it. Okay, well, we got a light in there as well. But yeah, it was if you've never used SceneKit before, I would actually say it was somewhat exciting. Let's do this, though. Let's add a little bit more to this same project. And what I'm going to do is I'm actually going to take out everything that we wrote starting from this let dummy node. So I'm just going to cut all this, all right, and then I'm going to put that into a function of its own. So function, let's just say add scene content. And one of the reasons I'm doing this is just so that we can basically kind of slightly time delay when this appears. As you guys all know by now, if you built this project with your phone or whatever sitting on your desk, everything is kind of oriented, from that initial starting position. So it would be nice if we could kind of, give ourselves just a few seconds to hold up the device and then kind of let things get started. And down the road, this is something you'd take care of by prompting the user to kind of establish themselves within their scene, maybe find a horizontal surface to lay things out on. But for right now, this at least help us out a bit. And it also introduces some actions for us. I keep wanting to say SCNActions, but now that we're in SceneKit, we should refer to them as SceneActions. But let's first deal with the errors that are popping up right here. Really, if we just go here and we replace out, and I don't even think we have to use self, but we can. If we just take this and all these places where we just start off by writing scene, if we put that in there instead, so self.sceneView.scene, and like I said, I think the self is actually a little bit unnecessary. And down here as well, that should take care of that. All right, so let's begin writing some scene actions. A nice thing is these are really kind of identical to, for the most part, they're pretty identical to SCNActions if you're familiar with SpriteKit. So you guys will recognize these right away. Scene action.wait for duration. Let's give people 3 seconds before we basically add things in here. And one of the more useful actions I think they have is to just call other functions, okay? And to do that, you write run scene action, and then we'll put in here scene action.run. And let's see, let's do this. I think all we have to do here is just not put in a particular node there. And then what we'll do is we'll write self.add scene content. Anytime you're writing within one of these blocks over here for a scene action, you just need to refer to the function with dot or self dot in front of it. And the only complaint they're giving us right now is basically we're just not using these. So let's now set up a sequence. Again, scene action, and even that you don't even have to write. It's kind of force a habit for me. So the sequence is just going to be an array with the previous scene actions that we already set up. So to create a quick little array here, just do your opening and closing brackets, put wait and run after. Actually, I want to name this run after. Run is not a good idea to write. There we go. I guess it's kind of reserved a little bit. So we'll put run after, as in run after that wait. And then what we need to do is just run this and or find. We could apply this to any other node in here, but we could also just come in here and put in here, refer to our root node. So we'll just put sceneview.scene.root node and then run action, and then we'll just put in there our sequence or SEQ. And what that should do is make it so that you just have a little bit of a time delay in getting that initial scene set up. And let's not even worry about testing it right now. Let's move on to doing a little bit of hit testing, which is the main topic of this video. And to do that, we need to be able to actually touch down on our screen. So let's go back over here to our, well, we're already there really. Our view did load, and we'll put in here a tap gesture recognizer. And you guys are probably so familiar with these. I'm just going to go ahead and paste this in. So we're going to write, but I'll talk you through it too. Let tap gesture recognizer, UI tap gesture recognizer. The target is going to be self, so this class. And then the action, you just put in here hash selector, handle tap. and then we can pass in information about the sender itself, so basically just where we're tapping down. And then we just need to add the gesture recognizer to the scene view here. And the complaint that it's giving us is that we have not actually set up this function. Okay, so let's just come right down here. At this point in time, if you do refer to a function with selector in front of it, there's a good chance you're going to need to put @objc here. It gets into some bridging, which if you're new to programming, I wouldn't even worry about it. Don't think much about it. So anyway, here's the sender, okay, and then you just put back the type of gesture recognizer that was. So UI tap gesture recognizer. And then from here, what we can do is we're going to do a little location test to see if where we tap down, if there's an object there, and then if so, and if it's the ball, then we'll basically apply a physics force to that. But if you're just kind of curious, check this out. You can, if you want to find out what information there is about the sender, okay, you can check that right here. Just write sender dot, and then you go through here, number of taps required, number of touches required, and we could have set that up over here as well. We could have said that our tap gesture recognizer dot number of taps required or number of touches required equals 1, 2, whatever it is. But by default, it's just going to be 1 and 1 for number of taps and number of touches. Number of touches would be the number of fingers that you are touching the screen with. Okay, so let's kind of back out of that. And what we'll do is, let's write guard, let scene view equals sender dot view as, and then we put in here ARS scene view, else we're going to return out of that. Okay. So basically just, actually, you know what? Let me correct that. We've already we've already declared a variable for our scene view. So we don't need to go and essentially find it again in this other function. This is a great line of code to just kind of hang on to, and to hang on to it. Let's just compress it a little bit. Let's go and put this over here. But again, yeah, since we've already declared that, we don't really need to do that. We could have done that. In fact, my notes still have that code in there. But we could just skip right down to this line. But again, if you hadn't declared the scene view earlier as a variable, then that is a good idea. And I'm sure you'll find references to that bit of code, plenty of places like Stack Overview and stuff like that. But you can see now, you know, we can just write scene view in here because we've already got that, right? And we're basically just getting the touch location. So sender.location in our scene view, that's going to give us a CG point variable to work with. And then what we do is we can write, and if CG point variable has an X and Y location, actually, yeah. I'm debating, does it have a Z location now that we're dealing with SceneKit? Maybe it does. So I don't know about that. Let's do let hit test result. Well, wait. Hold on. Now I gotta know. Dot. Is there a Z in there? I don't think there is. Let's see when we go. No, yeah, I'm not seeing a Z. So anyway, let hit test result. Let's try to spell result correctly. And this is going to equal scene view dot hit test. And you can see our options over here. We can pass in a CG point. We don't need to put any options in here. So go ahead and this is the one we're going to go with. Or actually, I'm sorry, we are putting in options, but it's essentially just everything. Okay, so we're going to throw in there just opening bracket, colon in the middle, and then closing one over here. Some of the options you do have, though, are interesting, and we will get into them. Things like if we are just interested in, let's say, existing horizontal planes, okay, we could put in there something like that, and we're bound to use that in a little bit. All right, so what we want to make sure is if the hit test result is not empty, so by putting in the exclamation point over here, we just write hit test result. If it is not empty, then what we're going to do is whatever is inside of here. And then if you wanted to write an else statement, you can put that down there, but we don't really need to. And then what we're going to do is we are going to iterate through. So we're going to write for hit result in hit test results. And you know what? Let's give this well, just think of this as possibly plural. Okay, so hit test results. There could be more than one thing that we've kind of touched against. Let's say, if there was a anchor point beneath the ball that we touched or something like that, or the box, right? So that's why we're iterating through this. We could possibly have more than one hit result. And if you wanted, you could put in here print hit result.node.name if you wanted to just, see what exactly we're touching, or I guess. But what I'll do is I'll just skip right down here to if hit result.node equals ball. Okay. Then what we'll do is we'll actually push that ball. All right. So basically this wouldn't run if we say had only hit the box. And we're going to put ball.physicsBody. Now remember, the physics body is optional. So when I write apply force over here, you'll notice that it puts in here this question mark, just implying that, hey, well, it might not have a physics body. And that's okay if it doesn't. It won't crash or anything. And then what we're going to do is we're going to move this. We're going to apply a force to this in a particular direction. And that's going to be written right here. So scene vector 3. And then we're going to put in here 0, 10, and 0. So we're just basically going to bump this up on the y-axis, okay, because that middle number is the y. And at least for a while, we could probably hit it a few times and it'll stay on that little box platform. And eventually it'll probably fall off just based on the physics body of the ball being not perfectly sphere. It's kind of geometric, so there's a little variation. But now, let's see. I think we are, and you know what? I guess I went all that way without putting in here touch location. How did that happen? There we go. Surprised it let me just continue rambling on. So there's the cliffhanger ending to this. And let's go ahead and run this project. So I'm going to do it on my end, and I'll be right back. All right, so here we go. Freshly screen captured. It's a screen capture of a screen capture right now. Okay, so we dropped the ball on here, and you can see, it might not have been clear, but I did touch the screen, and then it came back around. I'll do it one more time. There we go. Touch it again, and it falls back down. And eventually, there you go. You can see it just it goes into the floor. Okay, that's it. Well, actually, you know what? Let me show you guys the options you can throw in here real quick. I mean, these might not be too exciting because we're not really using them right now. But let's see. Existing plane. That's one of them. A plane anchor already in the scene. Detected with plane detection. We do actually have the hit return on that. We do have in our configuration set up to look for plane detection horizontal, so that would be another kind of key part of that. What just happened to that code? And then if you do, you can comma separate these. So another one is estimated horizontal plane is existing plane using extent. You can read about each one of these. Feature point, there might not be too many more, but at least for right now, you know that if you want to just kind of pick up on some of what's there with, your nodes and whatnot, this would be the way to go about that. And I'm sure there's another way as well, but we've talked 13 minutes now. Let's put this one to bed.